Greetings everybody. In the previous video I went over the creation of a basic particle system in C#, and today I'm going to be doing something very similar, but instead of with GDI Plus as I did previously, I'm going to be using XNA Game Studio, and it's going to be one for a great show today, one for an awesome show. I mean, first I've never used XNA really before, so this should be hilariously bad. And I've never used Visual Studio 2010 before either, so you know, that's two things I've never used before, and I'm trying to make a tutorial in them. It should be hilarious. We'll call it XNA Particles, because it has, you know, particles in it's in XNA. Alright, first step, we will rename game 1 to Particle Game or something. Something fitting. Factor, rename to XNA game. No, particle game. There we go. Now obviously, if we're going to be working with particles, we should obviously have particle class. Particle glass, right, that makes sense. So it's just going to be particle.cs, and it will have private vector 2 location, or underscore location, sorry. Using vector 2 obviously because XNA uses vector 2, vector 3, and I think there's a vector 4 as well for various properties, or akin to say pointf in GDI Plus. But it's not, because pointf is actually kind of limited in comparison. Velocity, and like it's akin from my previous tutorial, another one for velocity decay. And we'll just stop that out at 0.98f, 0.98f. There we go. And the accesses, public vector 2 location, get return underscore location, set underscore location equals value, public vector 2 velocity, get return underscore velocity, set underscore velocity equals value, public vector 2 velocity decay. It's probably not necessary, but yeah. Alright, set velocity decay equals value. There we go. And XNA, unlike in my previous one, I had the particle, if I remember correctly, there was a perform frame function, which performed the activities for each update, and a draw function that drew the particle, which both were separate, and if I remember the framework, drawing was actually done on a separate thread. This one, XNA, kind of has a similar prospect in that drawing and updating are separate activities. But there's a bit of a twist. Make update take as an argument an XNA particle game. A particle game instance, PG, not rated PG, but just, you know, particle game for PG. And game time, GG. We don't actually use this, I don't think, so don't get too excited about that. Now each update, the updates are pretty simple. Velocity times equals, so velocity decay, which I believe works in a scalar fashion. That could be dot product, I might need to change that, I don't know. And underscore location plus equals underscore velocity. And that's it for the update, amazingly enough. But there is actually one more thing. Since we don't want particles to last forever, right? So we need the same old song and dance. Time span, TTL, and we will make time to live, say, let's start it out as I'm going to say, let's say 1 second. And another one, private time span, live time equals new time frame, which will be empty to start with. And each update, oh, well, I guess I lied. We will use game time. We'll add on the game time. And what's this? Oh, no, game time to elapsed game time. And notice that I have a returning a bool. This was a, I'm sorry, planned lie here. The bool when this returns true, the particle is basically saying, hey, I'm dead, man. Put me in a coffin, put me out to sea, or whatever you do with particles when they die, which is nothing. And then the particle game, they're above, I'm going bad at this. The client that is managing the particle list, which in this case would be particle game, can destroy it. Simple enough. So basically we'll just return whether live time is bigger than TTL. Which is pretty simple. And public do void draw particle game PG game time GT. And this is where things get really interesting as I go to my images folder. And I got a nice little red speck here, which I think I'll use white speck. Oh, flippin', there we go. Add a new folder. Images, move that into the images folder. And the particle class will have a public static texture 2D particle texture. Yes, that's the one. And reload that and load content. Particle texture equals content.load texture 2D. Images, white speck. Alright, that's how you do that, I think. Yes, and this is going to keep something public, which is a split batch. Alright, and this is a draw. PG, oh wait, no, yeah, pg.spritebatch.draw. Draw our texture, particle texture, and a location. Some might wonder what this alpha color thing is. Well, first we need a percentage of the living time. So, float percent alive, or percentage. No, percent alive is far more positive. And we want the smaller divided by larger, which will be the smaller one will be our current living time, which is alive time. Or time alive, or whatever it was. Oh, I can't remember what I called it. That's great. Live time dot text. Convert it to a float, and then we divide that by ttl.tix, also convert it to a float, although I'm not sure that second one's really necessary. Oh well. Which will give us the percentage of our living time, which means 100% through when we're about to die would be 1. That's percentage. Which means we want the opposite value for how faded out we look. So alpha color will equal new color. Actually, we'll say 1 minus that. So percent alive times 255, percent alive times 255, percent alive times 255, and percent alive times 255. You'll notice a bit of a repetition there. I certainly have. 100% certain that will do the trick, but I guess we'll find out, won't we? Now, list the particles. Alright. List particle, our particles, equals new list particle. What? Oh, particles in public, is it? Well, that's going to change, isn't it? There we go. Draw. Alright. SpriteBatch.begin, SpriteBatch.end. Now do drawing code for each iterate in our particles, and iterate.draw this begin time. And in our update, we want it so that each frame or each update, so several particles spawn, so 4. int I equals 0, I smaller than 5, I plus plus. We will first create the random location. Vector 2 random pos equals... Oh wait, no, we don't need to allow. Vector 2 spawn location equals new vector 2 mouse.getState.x mouse.getState.y. Alright, we got vector. Now we need random speed. So float random speed equals rgen.next double times, say, 5. Type static random rg equals new random. Excellent. Get an E in there. Next double. And I think I might have accidentally canceled the recording, which is okay. No, it's still going. Good. I think let me double check. Yes, it's still going. Okay, good. I've done this on a few videos and it just stopped halfway through because of some stupid hotkey. Anyway, enough of that. I'm going to cast it to a floatsy. Not a floater, but a floatsy. Now we need a random speed. So, no, wait, not random speed. Yes, I know. So float random there equals new float. Okay, we need rg.next double multiply by math.pi times 2. All of that converted to a float. Alright, and vector 2 spawn speed equals new vector 2. Random x will be math.cosine. Oh, this is sine. Well, I don't think it really matters in this case. Random times random speed. Math.sin of random times random speed. Should give me the right one. We'll just cast that over there. We'll go to a float. And this one. Alright. And then we need a particle, so particle P. Oh, wait, you know what we forgot? Constructor and the particle. Never leave home without a good constructor. Particle, P location. Oh, wait, no, whoops, I did it wrong. Vector 2, P location, vector 2, P velocity, and location equals P location, velocity equals P velocity. Alrighty, back to the game, and we will just make that old particle P equals new particle with the random location, spawn, or not random location, but the location, random spawn location and random speed. Well, spawn speed, sorry, spawn speed. Not spa speed, spawn speed. I don't know what a spa would be. That's spelled that way anyway. And we add particle P to our particles. And that should do that trick. Then we update each one. This particle, remove these, equals new list of particles for each var iterate in our particles. F_iterate.update this and game time. Then we add them to remove these. Alright, then after that we need to loop again for each. Remove it and remove these. I'm trying to go a little fast here. And remove it. Particles. Remove it. I'm not 100% sure this will work. Oh, actually, the minus sign. And there you have it. Happy particles, which should be fading, but I don't for some reason. That's weird. Oops. Well, let's take a look, see, find out why it's doing that. A breakpoint here. Percent alive. 0. Oh wait, I should be multiplying by 255F, I betcha. It's probably trying to turn it into an 8 right away or some craziness like that. Oh, well, that makes me a sad panda. Should be working. By fading out, I mean. But it's not fading out. Crap. Open old Dodger X here. Not going to give away any state secrets, though. I'm not running it. Just examining its insides. Don't get any funny ideas. Use value 255 minus living percent. Get live percent, which is pretty much what I'm using. Curious. Wait. Oh, I thought it was the same for a second. Woo! I'm called it averted. Or disaster averted, sorry. 1 minus that divided by that. What if I was to multiply all that by 255 and then get rid of these multiplications here? I think I need to cast some data, but I'm not 100% sure. There we go, see? That's how you do that. Wee, particles everywhere, fading out and whatnot. Woo, scary. Wee, and that's how you do that. That is BC signing off with his awesome particle system of excitement. I will even put this in the description or upload it somewhere, rather than waiting for someone to ask what. So thank you for watching. Don't forget to comment. Tell me what you think of me, especially if it's bad. I enjoy healthy criticism. Help you out. I have a very bad breath right now. So if you're gonna insult me, try and work that in there somehow. Maybe silly head. Just don't go down with the doo-doo head there. I don't like that pathway. Anyway, toodles. Who says toodles nowadays, anyway?